Okay, apparently I'm live. I'm going to see what I need to do to share this. Share. Copy link. Right. Let's see. Go to... Nope. It's B. You can't hear me? Okay, let's see. I'm mostly just talking to myself at this point. You can hear? Okay. Anika, turn on your micro. Somebody message Anika and tell her to turn on her microphone or her sound then. This is serious. This is going to be kind of low tech because basically let me not hold on. I just realized that that you guys are going to see me typing in my password, which I would rather not. This is going to be kind of low tech. Basically, what I'm going to end up having to do is aim my phone at either my iPad or at the computer screen. And that's not ideal, but no, that's not the right link. I don't know. Okay, those of you that are on, if you go to the channel, can you see that I'm live, or do I need to send out a separate link that says that I'm live? Yes, you can see. Yes, if you see it on my channel. Fabulous. That's wonderful. Okay. You guys are fantastic. Thank you, thank you, thank you, thank you, thank you. Okay. So then here's what I'm going to do is this is going to be largely directed by what you guys need. I will answer whatever questions. I will go over whatever problems. I will, can we go over some of the problems on the online EOC practice test? That is not a problem. I'm going to have to pull up the link and get to those problems unless you can, but we can absolutely do that. So give me 1 second. And actually, it's probably easier if I do that on my laptop. And what I'll have to do is I can go over those and I can go over those and I can literally, if I need to, I can just write them down. Let's see. Geometry. Okay, computer practice. Please click here to... I know this is really thrilling content. Clearly, I'm going to be a huge YouTube celebrity. Geometry, FSA practice test. Practice tests. Computer-based practice tests. Sign in. Yes. So you guys know that the way that the computer system is laid out, that's exactly how it's going to be tomorrow. That's the exact settings. So you'll have all of the same resources, you'll have all of the same instructions, everything. Anika, which problem did you want to go over on here? Anika? Hello? All right, anybody? Number 2. Thank you. All right, problem number 2. Okay, I'm switching to view my laptop screen. All right, in the problem shown, chords A, B, and CD intersect at E. The measure of arc AC is 120, the measure of arc DB is 2x, and the measure of angle AEC is 4x. What is the degree measure? Yep, we can definitely go over rotations, Ava. What is the degree measure of angle AED? So let's see. I'm going to draw it real quick on a sheet of notebook paper. Okay. So we've got a circle. We've got 2 chords. This is 4x. This is 2x. A, B, C, D, E. And this is 120. Okay. So we remember that the rule for chords that intersect, for the angle formed by chords that intersect inside a circle, is that the measure of this angle is the average of the 2 intercepted arcs, so 120 and 2x. So 4x is going to equal 120 plus 2x divided by 2, because that's the average. 8x equals 120 plus 2x. 6x is 120. X is 20. That is not the question they asked us. They did not ask us what x is. They asked us for the measure of this angle right here. So if x is 20, then this angle right here is going to have to be 80 degrees. So then this angle right here is going to have to be 100 degrees. So the answer should be that the measure of angle AED is 100 degrees. All right, makes sense? This was problem 2 from the online EOC review session. Number 23 on EOC FSA warm-ups. You got it, Sharon. Or actually, Sharon, we'll do that after I talk real quick about rotations, because that was what Ava asked for next. Okay. Rotations. So let's say that I've got a point and it is 4, 3, and it's in quadrant 1, and I want to rotate 90 degrees counterclockwise. All right? So if I'm rotating 90 degrees counterclockwise, that means counterclockwise is going in the positive direction, so I'm going from quadrant 1 to quadrant 2. Okay? So whatever my point is, it needs to end up in quadrant 2. I'm going to switch the x and the y. The x is now going to be either 3 or -3. The y is going to be either 4 or -4. But if it's in quadrant 2, then that means that the x has to be -3 and the y has to be +4. There are rules, like you guys learned about whenever we first started learning about rotations. I don't like the rules. I don't like to memorize them. I would rather think about, okay, what quadrant is it going to be in? If I'm going 90 degrees either direction, clockwise or counterclockwise, that means my x's have to switch, or my x and y have to switch. They're not going to stay the same. They're not going to stay the same. But if you're rotating 180 degrees, then your x and y are going to stay the same. It's just they're going to be in a different quadrant, so they're both going to have the opposite signs of what you thought they were going to. So a 90-degree rotation, we switch x and y. A 180-degree rotation, x and y stay. Yes, exactly. I mean, you're never going to rotate a plane, but you've rotated lines, you've rotated all kinds of geometric shapes. So we just rotate each point on its own, and then that should end up with the entire shape being rotated. Does that make sense? So now, Sharon, you asked for number 23 on the GeoEOC packet, the GeoEOC words. Okay, thank you. Sorry, it's been a little bit of a rough weekend, and I'm very, very sleepy, and yeah, it's been a rough week. It's been a rough week for everybody, I think. Geometry, EOC, nope. That's not it. All right. Sorry, guys, I'm just trying to pull it up on my computer. EOC warm. Oops. There we are. I knew I had it. Okay. Number 23. Okay. So, in the XY coordinate plane, ABC has vertices. A is negative 4, 3. B is 2, negative 6, or 2, 6. And C is 2, 2. D, E, F is shown in the plane. What is the scale factor and center of dilation that maps ABC to DEF? All right, I'm going to do this one on the iPad just because then that way I can get graph paper real quick. Hold on. Sorry, this is like, it's not the most, I'm not being the most technologically adept that I probably could be, but this is, you know, we're all being really, really flexible, right? And we're going to celebrate being done with our EOC next week. Graph. Nope. Graph large. All right. So we're going to pretend that those are both straight and actually on grid lines. So we have triangle ABC. -4, 6, 2, 6, and 2, 2. Okay. We have triangle DEF. So looking at the picture, DEF, the ordered pairs for that are -2, 3, and 1, 1, and 1, 3. Okay? So, the first thing that I notice is that if I write down my set of ordered pairs, I notice that the ordered pair, the X and the Y for F, are half of C. The X and the Y for E are half of B. The X and the Y for D are half of A. Do you guys all see that? Anytime there is that obvious relationship, then it's helpful. Then that helps us to figure out both the center of dilation and the scale factor. The center of dilation is going to be the origin. And the reason that is because, remember, dilation is happening when we're changing the distance from the center to each point. So the distance from the origin to point C was 2 right and 2 up, yes? Now the distance to the corresponding point is 1 right and 1 up, all right? And that's working the same for all of the points. If we look at the answer choices are the center of dilation being either the origin or point B. And if the center of dilation were point B, then point E and point B would be the same point. And they're not. So that's not possible. All right? It's got to be the origin, because that's how it's the distance in relationship to the origin that's changing. All right? The other thing that we are asked is the scale factor. We are going from ABC to DEF. All right? We're going from big to small. So since we're going from big to small, that means that our scale factor has to be between 0 and 1. So that's going to be 1/2. All right, you understand the scale factor part. It's just not the center of rotation or the center of dilation that you're having trouble with, Sharon. Is that correct? So basically, what I would do in this case is they're not going... Okay, you got it now? All right. Yeah, what I started to say is they're not going to give you a problem where the center of dilation could be any point in the coordinate plane, okay? That's nuts. That's not going to happen. So if you're trying to find the center of dilation, look at the different points that they're giving you, and look at the different points that they're giving you and figure out which option has the distance that's a fixed, where the ratio is the same. All right, does that kind of make sense? I hope so. All right, what do we want for our next question? All right, good, I'm glad. Who's got another question? I haven't seen, let's see. All right, okay. I could over 34 and 35 on EOC review. Absolutely. The warm-up review, I assume, Nylia. So let's see. Constructions. Okay, so we have the first step of the construction is to draw an arc centered at point A that passes through point C and point D. What is established by the first step? Okay, so if this arc is centered at A, or if this circle that has this arc is centered at A, and it's going through points B and C, there's two segments, AB and AC, and those two segments, they're going to have to be radii of a circle, aren't they? Because even though we didn't draw the full circle, we drew part of it. We drew enough for it to intersect with two lines coming from the center, and that's the definition of a radius. So that tells us that we've got a circle, or we've got radii. The radii of a circle all have to be congruent, right? So AB and AC, therefore, are going to have to be congruent. And so your answer is going to be choice B. Does that make sense, Nylia? Okay, I'm not hearing anything, so I'm guessing. Okay, great, 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 good. All right, so then the next one is another construction. So this construction creates congruent triangles. ABD is congruent to ACD, not shown. Which statement provides evidence that AD is the angle bisector of BAC? Well, an angle bisector is going to create two congruent triangles, right? And if AD is the bisector, then that means that triangle, or the angle BAD and angle CAD are going to have to be congruent, which is answer choice C. Does that make sense? Yes, no, maybe? Okay. Okay, awesome. Good, 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 good. All right. What next? Question 7 on the EOC online EOC practice test, and then number 4 on EOC non-calculator. Not a problem. We will get to both of those. That's EDSB. Where's the EOC practice test? All right, number 7. It really doesn't like me that I'm just skipping right through these without answering them. Seven. Okay. Regular pentagon, EFGHI with center K is shown below. Select all the transformations that carry it onto itself. So we've got a reflection across line EK, a 180-degree counterclockwise about point K, and a reflection across a vertical line through point K. All right, I'm kind of failing to understand because, let's see, reflection across, okay. I think that they mean that that's all one transformation. This is kind of a really not well worded question. Because a reflection across line E, yes, I can. A reflection across line EK, that would work, right? But then a 180 degree counterclockwise rotation about point K. Would a 180 degree rotation around around the center, would that work at all? No, it wouldn't. All right. The central angle for this regular pentagon is 360 divided by 5, which is 1. Wow, I can't. I just all of a sudden lost the ability to math. Is that 108? 360? No, it's not. Oh my God. 360 divided by 5 is 72. Oh my Lord, y'all, it's been a day. Okay, so that's 72 degrees. So any rotation around the center is going to have to only be a multiple of 72. Okay, so I'm going to go ahead and strike through this one, and I'm going to go ahead and strike through I'm going to wait and not wait. A is correct. Okay. I'm going to draw it out. All right, let's see. All right, so can I draw a regular? Let's see. Nope. Okay. So, if I reflect this across line EK is going to be right here. Okay? That's going to wind us up with this being F, this being I, this being H, and this being G, but the shape is going to stay the same. Then when we rotate 180 degrees counterclockwise around point K, then we're going to have my point E being over here, and my shape pointing more like that. All right? And then a reflection across a vertical line through point K. I see what they're doing. I see what they're doing now. So rotating it 180 degrees turned it the opposite, or turned it so that it was pointing the opposite direction, but then reflecting it back across a vertical line, that made it so that it was the same. So choice A is going to work. No, I don't want to strike through it. Okay. All right. A 90-degree counterflexion across line FG and a vertical translation. All right. So that's going to put us so that all of our points have basically moved up here. Point E is staying where it is, but all of the rest are going over here. Okay. Then a reflection across line FG a reflection across line FG. Let me see where I am. These points are wrong. It's going to look more like this if we rotated it at 90. Where this is F, this is G, this is H, and this is I. And then a reflection across line FG, so that would put us over here. And then a vertical translation. No, that's not going to end us up where we started. A reflection across FI, so let's go. All right, FI is this line right here. I can't move it like I can on the smart board. All right, a reflection across that line would make our pentagon look more like this. All right, and then a reflection across line GH this is E. That stays the same. This is H. This is G. Okay. Then a reflection across GH. These two lines are going to be parallel. Okay. So when I reflect it again, I'm going to end up with the orientation being the same, but in a different location. And then rotating it 180 degrees clockwise around K, that's not going to put us back where we need it to be. So C is not going to work. All right. So let's try D. A reflection across a vertical line through point K. So here's my vertical line. All right. A 180 degrees clockwise rotation around point K. So if I reflected it across that vertical line, and then I rotate it 180 degrees, then I'm sort of mapping it back onto itself. And then a reflection across line EK. Well, this is actually the exact same, or very similar to what we did in part A. Okay, so it makes sense that those would result in us getting the same thing. Okay, and then a 180 degree clockwise rotation around point E, a reflection across a vertical line through point E, and a reflection across a horizontal line through point E. Well, think about anything that is rotated sorry, I'm like trying to draw and talk at the same time. All right, think about anything. Yeah, exactly, those are similar translations in a different order. Okay, so think about if we had a point right here, and then we rotated it counterclockwise, or we rotated it clockwise 180 degrees. Okay, so there's our new point. If we do a horizontal reflection, or a vertical reflection, and then a horizontal reflection, we wind up with that same point. Does that make sense? Hi, Nick. So even though this is a shape and not a point, since that's going to wind us up with the with any point in the same spot, that's going to end up giving us a the same, and that's going to end up giving us the same shape. That was like the world's worst explanation, so I apologize for those of you that asked for that one. If you could follow it, wonderful. If not, I'm sorry, and I can try to like record a video later on where I can go over that one again, thinking a little bit more straight. And then let's see, number 4 on EOC non-calc. What is the angle of rotation and the order of rotational symmetry for the figure? Okay, so the angle of rotation, that's going to be, how do we have to rotate this in order for it to match, it to be identical to itself? All right, so if I had this on my physical paper, then I would literally rotate my paper. Our options are 90 degrees or 180 degrees. Okay, I'm not going to turn my laptop, but I hope that you guys can see that If I rotated this 90 degrees, I'm not going to end up with the same shape, am I? But if I rotated it 180 degrees, I am going to end up with the same shape. So then the order of rotational symmetry, that's how many times I can rotate it and have it be the same in 360 degrees. So since the order of rotation, since the angle was 180, 360 divided by 180 is 2. Our answer should be choice B. All right? Makes sense? I don't remember who asked me for that one. I think that was that you, Sharon? I don't remember. I can look. Yep. Is it gonna, oh, okay, good. Is it gonna be hard? You know, I didn't have students taking this last year. I just had Algebra 2 and Trig Math Analysis. So, you know, your best bet would be to ask some of the kids that took it last year. I think that it will be challenging. I am also aware that the curve is substantial. So keep that in mind. You don't have to get 100% of the questions right in order to get a 5 or anywhere close to 100% of the questions right. Wait, it is what? Hard? The questions will be challenging. Yes. I think that, you know, Nick, I don't know what Miss Wilson gave you guys, but I know that with but I know that with what I've given my students, they found it challenging. This is what you guys need to remember. Every single kid in the state of Florida taking geometry is taking the same end of course exam. Anika, I do not know the answer to that question. Amber, you wanted me to go to number 4 on the online practice. It's a proof. So we're going to drag and drop. And this is a parallelogram proof. So given that PQRS is a parallelogram, and given that PQ is equal to QR, she wanted number 3. Did we do number 3? Oh. Okay, we didn't do number 3. All right. There are 3 highlights in the paragraph that show equations or phrases that are missing. For each highlight, click on the correct equation or phrase. All right. So, the vertices of SRT are 1, 4, 2, 2, and 1, 3. A reflection across the line blank. What is this practice test? This is, Nick, if you were to go to Google FSA practice computer based, you would get this test. All right. So we've got four options here. X equals 4, X equals 6, X equals Y equals negative X plus 5, Y equals negative X plus 6. All right. And then across the line, then we've got horizontal lines, and then these two is the same as a translation of 4 units to the right and 4 units up because the lines are congruent, parallel, perpendicular, or similar. Can lines be perpendicular? No, or sorry, can lines be congruent? No, they cannot. Every single line has infinite length. Can lines be similar? No, they cannot. So our answers are either going to be parallel or perpendicular. I hope you guys see that. Okay? All right. Let me draw this out. Okay, so we've got T is right here. R is right here. Oh my Lord. S is right here. Okay. We want to translate this 4 units to the right and 4 units up, because that's what we're trying to get to reflections to match that. Oh, what just happened? I guess my phone fell asleep. So 4 units to the right and 4 units up is here. 4 units to the right and 4 units up. 1, 2, 3, 4. 1, 2, 3, 4. That doesn't look right. 1, 2, 3, 4. 1, 2, 3, 4. Oh no, that is right. And then 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. Okay. That's terrible. It's a terrible drawing, but all right. If I were to reflect across a vertical line and then a horizontal line, am I going to get the same shape that I have here? No, I am not. If I reflect across a vertical line, yes, you will get graph paper. If I reflect across a vertical line, for example, right here, x equals 4, and then I reflect across a horizontal line, then I'm going to end up with the same shape, but it's going to be rotated, okay? It's not going to be exactly the way this is, okay? So if we want to end up with a translation, we need to reflect across parallel lines, all right? So now we need to pick some parallel lines. All right. So our options are y equals negative x plus 5, y equals negative x plus 6. Yes, we can. Y equals negative x plus 10, y equals negative x plus 12. Okay. So if I'm reflecting across the line y equals negative x plus 6. All right. That's this line right here. Okay. What I'm going to do to make that happen is I'm going to pick a different color. I'm going to move, basically go this, and this works because this is this has a slope of -1. I'm going to go to that point horizontally and then up vertically. That's R. All right. 2 to the right, 2 up. That's T. 1 to the right, 1 up. That's S. My drawing's terrible, but do you guys see that that's a reflection? All right. And then if I wanted to do the same thing to get from the purple one to the blue one, my line would need to go through here. Because that's, oh, well, no, I don't want to do that. I don't love this program. It's challenging. Anyway, so let's figure out what this line is. Okay? So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be the line negative x plus 10. Okay? So let's see if that's one of our options. All right? We tried it with negative x plus 6. And then negative x plus 10 is an option. All right? So I'm going to save it. I don't know if it checks my answers at some point, but I posted the answer key to this. Is that answer correct? Can you please explain why the transformation has to be through parallel lines, not perpendicular lines? Yes, no problem. Okay, the only way to wind up with the transformation that is the same exact shape, that's parallel, or that's a translation and not a rotation, is to reflect through parallel lines. If you reflect through perpendicular lines, you are going to end up with something that has been rotated 180 degrees from the original, which in some cases is what we want, but in this case we were told specifically that we wanted a translation 4 units to the right and 4 units up. So translation reflect through perpendicular lines, through parallel lines. Rotation, reflect through perpendicular lines. Does that make sense? All right, so let's see. We've got next 28 from the EOC warm-up. Oh, no, let's practice test warm-ups. 28, nope, that's too far. Okay, an archaeological team is excavating artifacts from a sunken merchant vessel on the ocean floor. To assist the team, a robotic probe is used remotely. The probe travels approximately 3,900 meters. You will have the calculator on the second day, Atia. At an angle of depression of 67.4 degrees from the team's ship on the ocean surface down to the sunken vessel on the ocean floor. This figure shows a representation of the team's ship and the probe. How many meters below the ocean, surface of the ocean will the probe be seen, or will the probe be when it reaches the ocean floor? Okay, so what they want to know is they want to know this distance. They want that vertical distance. Okay, so this is actually a trig problem, and I don't need a graph for that. So let's draw some lines. Here's the surface. Here's the probe. There's the path that the probe traveled. Nope. That is 67.4 degrees. All right. This is the distance we're trying to find. This distance is 3,900 meters. Okay. If this angle is 67.4 degrees, then so is this angle. They're alternate interior angles. This side we're going to call x. We've got the opposite side and the hypotenuse, which tells us that that is going to be the sine. Okay? So we are doing sine of 67.4 degrees equals x over 3,900. Okay? I hope everybody sees why it's the sine. And then we multiply both sides by 3,900. X equals 3,900 sine of 67.4 degrees. Okay. Let me use your EOC calculator. Okay, I just want the calculator. Maybe it won't let me use the calculator. Anyway, so we've got 3,900 sine of 67.4 degrees. I don't actually have a calculator with me right this second. So I can't type it in. It's fine. You know how to use the calculator. Okay, cool. All right, good to know. Awesome. All right. What was next on the list? 28 from EOC warm-up. Cavalari's principle works. Yes, no problem. So Cavalari's principle basically states that if you've got a shape that is, if you've got a solid, like for example, a box. I just realized you guys were getting a shot of my knee. Sorry about that. Okay, we are going to pretend that that is a rectangular prism that is perfectly right and not at all tilted, okay? And let's say that we know the length, the width, and the height, okay? What Cavalari's principle says is we can have a similar shape, and I'm using similar as in like that shape, but not exactly. Okay? And my drawings are absolutely atrocious, and I apologize. As long as the length and the width are the same, and this distance is the same, then I haven't changed the volume of this shape. Basically, what I'm doing is cutting it into very, like, thin cross sections, and I'm sort of, like, slanting it, okay? But I haven't changed the volume because I've still got the same length, width, and height. Each of the tiny cross sections is still the same, and the height is still the same. The volume of a prism is length times width times height, and if none of those measures are changing, even if the location of those measures changes, then the volume can't change. Does that make sense, Sharon? Awesome. Okay. All right, and then 13 on the online test. Okay. Circle A has a center at the origin and point D located on the circle at 1, 0. Circle B has a center at 1, -2 and a point E located on the circle at 4, -2. Logan performs 2 transformations on circle A to show that circle A is similar to circle B. He first dilates the circle with the center of the dilation at the origin and then translates the new circle. What are the algebraic descriptions of the 2 transformations? All right, so we've got our circle A, our circle with center A has a radius of 1. Our circle with center B has a radius of 3. 1, 2, 3. So the first dilation is going to have to be 3x and 3y. Because we need to multiply every point by 3 to get the circle to have a new radius of 3. Okay? Then we're shifting it. And let's shift the center. All right? Rather than shifting any other point. So the center was 0, 0. The new center is 1, -2. So we're going to do x plus 1 and y minus 2. All right? And that's all there is to it. And that should be the correct answer. I don't have the answers to this right now. Why are you bothering looking at my computer screen, Nicholas? Learn geometry. How do you determine, all right, awesome. How do you determine whether they're asking for surface or lateral area if they don't specifically ask for it? They have to specifically ask for it. If it's surface area, you guys know that it includes all of the parts, including the bases. If it's lateral area, then it's not going to include the bases. But they're not going to, but they can't possibly ask you a question where it doesn't specify which of those it is. Okay? They've got to specify. Okay? Sure, and if you have an example of what you're talking about, I can go over it. Rima texted in one that she wanted me to go over, so let me see if I can pull that one up. Hold on. I gotta get it from her mind. Really? Why am I not? Okay, if I switch off of this, it might stop the live for a second. Hold on a second, and we'll see what happens. Okay. Hey, I'm in the middle of a live YouTube session, a review session with my students, but come on in. Sorry guys, my mom just got here. Let me go to remind on my computer so that everybody can see that problem, since I don't know where it came from other than my mom's last name is not Funk Nicholas Suarez. My mom's last name is Erlenbach because that's what my name was before I got married. Okay. All right. Someone just robbed a bank. The police set a triangular perimeter of 16 kilometers where the robber might be hiding. 2 of the 3 coordinates for this triangular perimeter are 2, 2, and -2, -1. Each unit represents a kilometer. The area covered is 12 square kilometers. Which of the following is the 3rd coordinate of the triangular perimeter? So let's definitely use graph paper for this. All right. So 2, 2, and -2, -1. Okay. So each unit represents a kilometer, and the area covered is 12 squared kilometers. So let's see. Our options are 2, -4, -2, 4, 2, 8, and 6, -4. Okay? So, I'm just going to go through them answer choice by answer choice. All right? 2, -4. 1, 2, 3, 4. That's right here. Okay? That would mean that that's our distance. Okay? So we want our area to be 12 kilometers, or 12 square kilometers, which means that we need our we need to have the height and the base length. All right, the base 1, 2, 3, 4, 5, 6. The height would be the distance, the distance from here to a point here. So that's going to be 3. Okay? The area of a triangle is 1/2 base times height. So that's going to be 9. That's not what they wanted. They wanted it to be 18. They wanted it to be 12. So I don't see how that could possibly be the correct answer. And I think that whatever resource you used for this had the incorrect answer. So let's try a different point. All right. -2, 4. -2, +4. Okay. Here you would have to, you don't have any vertical or horizontal distances. So you would have to find the area of this triangle using, you'd have to find the area of this triangle using, by basically finding the distance from this point to this line for the height, and then finding this distance. There is an easier way to find the area of a triangle using coordinates. I do not think we know it. So let's see. 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Again, this time the base is 6. The height is 3. So this is not going to give us the, this is not going to give us an area of 12 square kilometers. It's going to give us an area of 9 square kilometers. And the difference between this one and the first answer choice is going to be the perimeter of the triangle. And I hope you guys are seeing how you would find the perimeter of the triangle. You would have to do the distance formula and add up all 3 sides. I'm not going to do that right now because it would be time consuming and I don't have a calculator with me, but that's basically what it would be. And then the last point, 6, -4. 6, -4. Again, we would have to find that distance. And we would have to find that distance, and we would have to and then once we did that, we would have to find this distance to find the area. Rima, are you still here? I don't know if it can show me who's watching, but okay, well, I don't, Jesse, no, you don't need to turn anything in tomorrow. We will deal with everything that has to get turned in on Thursday or the following Monday. I am not concerned about anything getting turned in tomorrow. Well, number one, you wouldn't have had class tomorrow anyway. Number two, because tomorrow's the day 2. Number 2, I'm more concerned about you focusing on your EOC, and anything that needs to get turned in tomorrow, or anything that needs to get turned in, we can deal with after that. I've been out for a week. Deadlines are like the least of my worries right now. Rima, I'm going to mess with this problem later on. I would love to know where you got it from, because I would love to figure out what the deal is with it. But as at the moment, I do not believe that the answer that was given is the correct answer at all. So, Nick, I'm going to kick you out if you don't stop. What other questions do we have? $29 on the online test, no problem. And then 36 on the warm-ups. Not a problem, Tim. We'll do that after that. Lillian T, I don't know who you are. Please get off this live. This is for geometry review. Samuel Trejo that is in trig math analysis and does not have to take this? Yeah, no problem, Atia. We can definitely do that. All right. The Leaning Tower of Pisa is 56.84 meters long. Nick, that's enough. Ava, if you want to go ahead and try to find a problem anywhere in any of the resources that you guys have that relates to apothegms that you want to go over, I'm more than happy to. Just go ahead and find one, okay? All right, so the Leaning Tower of Pisa is 56.84 meters long. In the 1990s, engineers restored the building so that angle Y changed from 5.5 degrees to 3.99 degrees. To the nearest hundredth of a meter, how much did the restoration change the height of the Leaning Tower of Pisa? So we've got two problems to do here. They're both trig problems. They're both going to be SOHCAHTOA and right triangle trig. Okay? So the first one we've got Nicholas, I have your mother's phone number. I could call her. All right, so this is 5.5 degrees, and this is 56.84 meters, okay? So what we need to do is we need to figure out this distance, okay? So here's our angle, and this is not an angle that's in the usual spot that we would think of it being, okay? But so the two sides that we're dealing with, H is going to be the adjacent side, and then this is going to be the hypotenuse, okay? So that's going to be cosine. We're going to have cosine of 5.5 degrees equals H over 56.84, okay? So then you would solve for H, and that would give you that would give you the height, and that would give you the height that the tower was before. Okay, so now I have the calculator, so I can do cosine of 5.5, close, enter, and I'm going to multiply that by 56.84. Oh, I forgot. Okay, cosine 5.5. So guys, if you use the computer calculator, it's going to be a lot more like using your graphing calculator than the ones that are provided to you to use by hand, okay? So I would probably use the computer calculator when you need to. So that's going to be 56.57 or 56.58 meters tall originally. Okay, So now we've changed the angle, okay? And now, instead of the angle being 5.5 degrees, it's going to be 3.99 degrees. All right? So we have a new height, and we have the same hypotenuse. So this is going to be cosine of 3.99 degrees equals our new height, which we don't know, over our hypotenuse, which is 56.84, I think. I forgot it already. So, yeah, 56.84. So, we're going to back to our calculator. We're doing 56.84 cosine of 3.99. And that's going to give you the 56.70. So yeah, you're just calculating the difference in the two heights. So you're going to do 56.70 minus 56.58. And the answer is going to be 0.12 meters. 0.12. Okay? Questions on that one? All right, let me go back to what we needed. 36 on the warm-ups is next. Okay. A steel pipe in the shape of a right circular cylinder. Okay, where are we supposed to meet? Where are we supposed to meet to take the EOC in the morning, and does it take up the whole day? All of my students are going to room 421 tomorrow morning. Miss Wilson's students have a different location, and that is room 309. Thank you. I think a handful of Miss Wilson's students are also testing in room 309, but every single one of my students is in room 421. Everybody tests for a minimum of 90 minutes. You will be in the testing room for 90 minutes. And then if you are finished after 90 minutes, then you can leave. Okay? If you are not finished after the 90 minutes, then you will, if you are not finished after the 90 minutes, then you will have up to half the length of a regular school day. So you will have up to 4 hours. Nick, at one point, Miss Fitzgerald sent out the list of testing locations via Remind. I don't know if she sent them to just teachers or teachers and students, but that would be how Anika knows. All right, a steel pipe in the shape of a right circular cylinder. The length of the pipe is 12 feet. And its diameter is 36 inches. The pipe is open at both ends. Okay, Sharon, here is a key question. Here is an example of that that question that you had about surface area and lateral area. It says the pipe is open on both ends. So that tells us that this is only going to be lateral area. There's no ends, so it's going to be just the lateral area. So the length of the pipe is 12 feet and its diameter is 36 inches. The pipe is open at both ends. Okay? So we are looking for the lateral surface area of this cylinder. The lateral surface area is 2 pi RH, okay? And the reason for that is because, the reason for that is because if you took this cylinder and sliced it and unrolled it, then basically you would have a rectangle with the height being obviously the height and the width being the circumference, 2 pi h, okay? Now, the diameter of this pipe is 36 inches. And actually, since it's diameter, we could also say, or 2 pi r rather. Since it's diameter, we could also say diameter times pi times diameter. Okay? Here's the thing. They're asking us for square feet. The length is in feet. The diameter is in inches. So we need to change the diameter to feet. Since it's 36 inches, the diameter is going to be 3 feet. Make sense? Okay, Ava, thank you. We'll look at that in a minute when we're done going over this problem. So the height is going to be 12. The circumference is going to be 3 pi. So this is going to be 3 times 12 times pi. And it's going to be, which is going to be 36 times pi. And calculator. Clear. 36 times pi. Enter. And that's going to be 113.09. But since we were told to round to the nearest integer, that's going to be 113 square feet. Make sense? Any questions on that for those of you that, I think, Tim, was that your question? I've forgotten. I think it was. Yep, that was your question, Tim. All right. Okay, awesome. Good to know. All right, so then let me pull up the practice test, or the study guide for your test, and then that way I can, let's see. Nope. Wait, I know where it is. Sorry, I have to talk to myself. Sections 11. Section 11 through 13 study guide answers. Where's the study guide? Okay, so Ava and Atia, if you look at this problem right here, consider the regular nonagon with a given center below. If the nonagon above has a side of m inches, then determine the length of the apothem A. Okay? And I wish I could draw on, draw on here the way I would normally. But I can't. So what I want us to do is to go ahead and think about drawing the apothem from here to this side right here. Okay? That's going to be, because this is, because this is a regular polygon that's going to form a, and that's going to be perpendicular to this side. If I were to draw this segment and this segment, all right, I would have isosceles triangles, all right? I hope you guys all see that, okay? Let me draw. Let me make an attempt. 2, 4, 5, 6, 7, 8, 9. We're going to pretend that that's anything resembling a regular polygon. It's not, but we're going to pretend. Yes, I can. All right. So, if this is a nonagon, then this central angle right here, the definition of an apothem, Jesse, is the segment that goes from the center of a regular polygon and is then perpendicular to one of the sides. All right? So, if I've drawn all of these isosceles triangles, and all of these segments I'm drawing, those are radii of this regular polygon, okay? So all of these angles together have to add up to 360. So when I divide that by 9 of them, because that's how many there are, we get 40 degrees. Okay? Now, the apothem is a special segment in a triangle because it is the altitude, which I hope everybody sees. But it also, because this is an isosceles triangle, this also happens to be an angle bisector and a perpendicular bisector and a median. It's all 4 of them. That only happens in isosceles triangles when you're drawing those segments to the base. Okay, so those 2 segments are congruent. Okay, this angle right here is going to be 20 degrees. And since we were told that the side length is m, this segment right here is going to have to be m over 2. Okay? The length of the apothem is a. All right? So, yes, there are 9 different apothems, Jesse. They would all have the same length, so it wouldn't matter which one you drew. I always like to draw the one that's like perpendicular, that's like vertical and at the bottom. Okay? So, our angle here is 20 degrees, right? This is a right triangle because the apothem, by definition, has to be perpendicular to the side. All right? So now we've got opposite and we've got adjacent. So actually, let's look not at that angle, but let's look at this angle. Okay? Since this is a right triangle, if this is 20 degrees, this is going to be 70 degrees. Okay? So then A is the apothem, that's the opposite. And then m over 2 is the adjacent. Okay? So we have A over m over 2. We're then going to multiply both sides by m over 2 so that we get that A equals m tangent of 70 degrees over 2. Okay? Does that clear up some stuff about the apothem? If you have other general questions about it, I'm more than happy to answer them. And then I know we have a couple of other questions on deck to answer. But if there's questions about apothem, then I'll definitely answer them now. All right, Atia, so you're good. Is that the final answer? Yes, it is. What is the formula for the apothem? There isn't really one. You're going to find it by doing that process that I just showed you. In some polygons, the apothem is really easy to find. In a square, for example, you basically don't even need the apothem. It's always going to be half the side length. In a equilateral triangle, then the apothem is going to be able, you're going to be able to find it using the fact that there's 30, 60, 90 triangles. Same within a within a hexagon, it's going to involve 30, 60, 90 triangles. It's not going to be that straightforward in any other shape. So you're always going to need to do the tangent. Okay? Let's find the previous or the next question. So number 1 on the next page of this review packet, and then number 3 on the calculator practice test. Okay. All right, so use the regular polygon with a center to answer the questions. All right, so looking at this regular polygon, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, okay? So actually, we can use the information that we just found, okay? So this is a nonagon. And we just found that the apothem of a nonagon is m tangent 70 over 2, okay, where m is the side length. If it were any other type of regular polygon, any other number of sides, we would have to go through that tangent process to find the apothem, okay? We know that the side length is 13, so this is 13 tangent 70 over 2, okay? Now, why does that matter? It matters for a couple of reasons. Looking at this, we're trying to find the area of that dotted triangle. Well, the area of a triangle is 1/2 base times height. And isn't the apothem going to be the height of the triangle? So that tells us that the area is going to be 1/2 times 13. Oh, I'm completely out of room. 1/2 times 13 times 13 tangent 70 over 2. We would put that in the calculator. We would get the area, round it to 2 decimal places. You would get that it is 116.08 square inches. All right, then to find the area of the regular polygon, you can do it in one of 2 ways. The first way, and probably the easiest way, is how many isosceles triangles am I going to have? I'm going to have the same number of isosceles triangles as I do sides. 9 sides, 9 isosceles triangles. Take the area of this one isosceles triangle and multiply it by 9. Make sense? There is a formula, and that's the second option. The formula for the area of a regular polygon is 1/2 the apothem times the perimeter. Okay? Now, isn't the perimeter the number of sides times the side length? So, isn't the perimeter 9 times 13? So, I'm basically doing the same exact thing. It's just two slightly different approaches to how I make it happen. But in general, they're the same. Does that make sense? All right. Sharon asked for number 3 on the calculator practice test. Real quick, Vidu, what is a composition reflection? It's a reflection across any two, it's a reflection, basically reflecting across two different lines. So first you reflect across one line, then you reflect across the second line. Nylea, how do you find the number of polygons a diagonal of polygons has, and does it have to be regular? No, it does not have to be regular. The number of diagonals, there is a formula, Taylor was right, is going to be n times n minus 3 over 2. Okay? And here's why. I'm going to draw a shape. I am not making it regular at all. Okay?
Do you need this?
Yes. All right. So let's draw all the diagonals that go from this point right here. Okay? I can't draw a diagonal to that point because it's there. I can't draw a diagonal to that point because that's a side. I can't draw a diagonal to that point because it's a side. Okay? So I've now drawn 3 diagonals. There are 6 sides. N minus 3. Okay? I do that with every single vertex. So that would be n times n minus 3. But hopefully you see that that's going to actually give me twice the number of diagonals that I should have. Because when I get here, one of those diagonals is repeated. And as I go around doing it for the entire polygon, I'm going to end up with having twice the number of diagonals that I should. So that's why I do the divided by 2. Okay. I saw a request problem on finding the distance between 2 parallel lines. Yes, I can do that. But let me do number 3 on the calculator practice test first. Okay. Okay. Hi. Who actually is this talking? Whoever is using the account, Zachary. All right. So we have, oh, hi, Olivia. So we have AG equals 21. We have ABF is congruent to EDG. ABF and GCF are equilateral. And since ABF is congruent to EDG, then that's also EDG is also equilateral. AG is 21. And CG is 1/4 AB. Okay? So, what we have here, and I'm going to try to draw this out. Not perfect. Shocking. I'm sure that you guys have all really come to expect very perfect and drawn to scale drawings from me. Okay. So AG is 21. Okay? Since this is an equilateral triangle and these two are congruent, all right, we're going to say that that's x, okay? This side is 21 plus x. Therefore, this side has to be 21 plus x, and EF has to also be 21, okay? If FG is x, then this has to be x, and so does this, right? If this is equilateral, then AF is 21 plus x, so AB is 21 plus x, and DE is 21 plus x, okay? CG, which is x, is going to be 1/4 AB, okay? So x is going to equal 1/4 21 plus x. All right, let's solve that equation. 4x is 21 plus x. 3x is 21, so x is 7. Okay, so now let's go back to our picture and label the side lengths. All right, this is 28. Okay, this side is going to have to be 21 plus x. This is x, so then this is going to be 21. This is going to be 21. This is going to be 28. 28, 21, 28, 21. Add them together, you get 98. Okay? I don't remember who asked for that, but if whoever it is, are you okay with that? Wait, Olivia, did you really literally just like Google or like search on YouTube for geometry videos and you came up with my live stream? That's interesting and a little alarming. Finding the distance between two parallel lines. Okay. So I'm going to make up a problem unless you have one for me, Olivia. That's hilarious, but good to know. All right, so let's do the lines y equals 4/3 x plus 7 and y equals 4/3 x plus 2. And this may end up with the numbers being super duper ugly, and if it is, then I'm sorry. Okay, I am going to pick a point on this line, okay, on the second line. The very easiest point to pick is going to be the y-intercept, 0, 2. I hope you guys all see why that was the easiest point for me to pick. Now, I'm going to find Nicholas Suarez. Do I need to text your mother? I will text your mother. Next, I need to find the distance between this point and this line. There are two ways of doing that. One is easier than the other, okay? However, the one that is easier requires you to know a formula that you may or may not know, and I'm more than happy to give it to you, but you know, it's just one more formula that is not provided to you that you'd want to know. Okay? So, I'll do the hard way and then I'll do the easy way. The hard way is we've got y equals 4/3 x plus 7. Okay? I need to find a line perpendicular to this that goes through 0, 2. All right? Fortunately, because we picked the y-intercept, that's actually pretty easy. The line perpendicular to this is -3/4 x plus 2. Okay? Then we have to find the point of intersection between these, the intersection point between these two between these two lines. Yes, Xiomara, you do get formulas. If you Google FSA geometry formula sheet, I will tell you it's not super duper helpful. They have basically sine, cosine, tangent. They have a couple of volume formulas, and that is pretty much it. So I'm finding the intersection between these two. So negative 3/4 x plus 2 equals 4/3 x plus 7. I'm going to multiply everything by 12 to get rid of the fractions. I get negative. They do not tell you which is which either. That is 100% true. Negative 9x plus 24 equals 16x plus 84. Okay, so this is going to be negative 25x equals 60, x equals 60 over 25, which is 12 over 5, which is 2.4, okay? So if x is 2.4, then I plug that into one of the two lines, and it does not matter which. You could use the distance formula to find the distance between 2 points on a line, but not to find the distance between two lines, because it's got to be the shortest distance. Okay, so going back, negative 3/4 x plus 2. Y equals negative 0.75 times 2.4 plus 2. And that's going to be, oh, it's actually easier if I do it as fractions. Negative 3/4 times 12/5. I've got a point that's on this line that is the closest point to here, or to this point, okay? And so that's going to be, if you find the distance between them, that's going to be the formula, okay? So the alternate way of doing it, hold on. They're at Scott and Shirley's. I have to go get them.
Tonight?
Uh-huh.
Oh, good. You know where that means we can go. Why are they at Scott? Oh, because you have to say.
Mm-hmm. All right. I have no idea if any of y'all can see me, but there's a formula that's helpful. Okay? This is the formula for the distance between a point and a line. Okay? That formula is, if the point is and the line is ax plus by plus c equals 0. The distance is going to be a times x1 plus b times y1 plus c over the square root of a squared plus b squared. Okay? So again, you find a point on the and it's easiest if you find a y-intercept. All right? You have to put this line in slope, the point on the other line in slope-intercept form. In standard form. And then you use that formula. Okay? So listen, here's the deal. I've now been going for almost 2 hours. I haven't eaten anything. I have to drive to Plant City and get my dogs. I would very, very, very much love to continue to help you guys. And what I'm going to ask you to do is to send me through Remind or through Edsby, for those of you that aren't members of my Remind and can't message me on my Remind, send me questions, and I will record one more video and upload it to YouTube tonight, and with answers to all of those questions, okay? But I got to eat something, and I got to get my dogs, and I am more than happy to help as much as possible. All of these messages that all these questions that you guys are putting in the comments, I don't know who has their screen name is Donald Trump, but you're not that funny. All of the questions that you guys have, send them to me on Remind or on Edsby, okay? If I have a question from you by, what time is it? If I have a question from you by 9 p.m. tonight, I will answer it and put it in a video, okay? And then I'll upload it.
Limit the number of questions.
So send me those questions, and I will do what I can. I'm glad this was helpful. The video, the whole almost 2 hours is now on my YouTube, or will be on my YouTube channel, so that you guys can have so that you guys can go back and watch it. And you should see all the comments as well. There's at least a little bit of just like, you know, dead air, but most of it should be helpful. I will see you guys tomorrow. Good luck. You guys will be great. I promise you. Okay? You will be fine. I love you all. Even you, Nick. And I will talk to you soon. Okay? Have a good night.